after that, we talk about review and exam review, and we have next Thursday, the last lecture for 234, next Thursday. And it will be the last meeting for 234. And your exam will be on 6th of November, from what I know, 6th of November. And we will have one office hour. I have set up an office hour. I will talk about this on Wednesday when I have review. If you have other questions, you can send email and set another meeting if necessary. So this is how we are going to work for the last part, as I mentioned. Before, most of your assignment marks are up. Assignment part 2 marks will be up 20th of this October or 21st of October. This is the best we can do. And then optional assignment, after you submit it, it's 23rd. Hopefully we won't be so busy, and by end of October you will know all your marks, practical marks. All you have to worry about will be exam performing, but hopefully you will do well. If you have done your assignments and worked on tutorial exercises, no problems will appear, hopefully. So, any questions? We covered inheritance, and we talked about base classes, normal base classes, and here we have a rectangle type base class. As you can see, everything is inside the class implemented. In Java, this is how it is. You can't implement outside. Good practice, put visibility specifier for all your notions. Data members, protected or private, you choose them. Method, public, you might have private methods if you want, but be aware you have to put this. So this is on your string. It's called simple inheritance demonstration. You have this file in string. What we do here, for the rectangle, we have 2 data member length and width, and what we are interested is in computing area and representing our rectangle as a string. Now, last time I said the object, which is a root of all, it's in the end, a parent for all classes is an abstract class. I was wrong. It's not an abstract class. It's a complete class, which comes with those prototype clone equal to string, but they provide some basic behavior, but they are there mostly to allow us to overload them. If we overload to string, notice what we do for converting a rectangle to string representation. We construct a string from various data associated to our rectangle, and I put there length, width, and area. And this is a string which characterized rectangle objects. If you have this method implemented, then when we use system out print line, my object rectangle for rectangle 1, that R1 will be this string. So we get the display on screen. Because of this, you can, by analogy, notice that this is the way to perform output overloading. other than that, what we have here, constructor, a method called set dimension, and we have some minimal checking. Dimensions should be positive. If they are, we accept them. If they are not, we provide default values. And then we have accessors, get length, get width, and some useful function to compute area and the length, total length of the sites. So these are simple formula, right? And two string. So this is a base class. And then the derived class comes with a new dimension. This box is meant to be a cube. A cube, or not necessarily a cube, parallelepiped like this. It's a parallelepiped. It has a rectangle as a base and it has a height on top, right? So we want to reuse what we have for rectangle and construct objects of this type. It's a derived class. As you can see, it comes with an extra data member. And then we have the constructor, and this is what you have to use in your assignment for derived classes. Super and whatever. We have another constructor. So we overload. This is a default constructor. This is a custom constructor with the 3 parameters. And notice how we use, again, the super invocation. Then for dimension, set dimension, because we have 3 dimensions. Notice we invoke super for calling the set dimension of the base class. So we reuse code. This is why we want to use derived classes. We don't have to rewrite what does it mean set dimension for the base. It's there, we just use it. And then get width is available here, is available to the get width, to the box class. But you notice we don't have it here. It comes from the base class. We don't have to rewrite it. Get width and get. So this get length and get width, once we define them in the base class, we can call them if we need them here. They are available. Even if we haven't listed them, this is what inheritance is. It is the same in C++, it is the same in Java. Looks like new things for some of us. Right. Remember, only what is private in the base class cannot be directly accessed in the derived class. But what is not private, and here, this get width is a public, it's available to everyone, but what is available to everyone via an object of the rectangle class. Now here we can use get width and get side, get width and get length if we need it. If we need it to perform something. All right. But what we have here is an extra method to get the height. So for area, we have a different formula. When you compute the area of a parallelepiped, you have to do something like this. So we don't use super. But for the volume, notice the volume of a box is area of the base times the height. And area of the base is rectangle. So we return the rectangle area times height. Once again, we don't repeat writing code. we use whatever we need and is available in the base class via invocation to things which are there. And this is why inheritance is considered a good thing. It's efficiency of code writing plus other. If you change the area formula for the area, you change it only once in the base, and then it comes here automatically. So one change in one place set up the whole thing appropriately. Now for string, you can return super, so the base part to string, right? But then we had length, width, and area, and it's not quite right. We have surface area, which comes with this, and we have to add height and volume. So in this place, I put in place straight away the formulas. Notice again that width and length are coming from the base class. We don't have data, but because they were protected here, they are straight available here. Length and width, okay, and this is how it works. Now, after you put in place this, you can put together this simple program. As you can see here, we have a base class object, which is fully constructed, and this is available because our base is not abstract. We can construct rectangle objects. Now, here we perform polymorphism. Notice that object base was a reference to a rectangle, but now we initialize it with a derived type object. This is what you will have to use in your assignment. In the main function. In the main function, you remember maybe for your assignment 2 part 1, you had pointers to employees. It was given that name, I think, in the handout. Pointer to employees, but then you initialize elements in that pointer to employees from objects of temp type, object of professor type, object of administration type, because you want to compute their salaries and add it with a for loop. Similar thing will happen here in your assignment, and you will have to use something like that. Objects to the base class, but initialized with objects of the derived type. And I said in Java, this is the default behavior. Polymorphism, it's by default. As long as you get this set up, initialize references defined as references to the base class type from objects of the derived type. And then you can go with for loop and invoke area or pay. And the function is called appropriately based on the type of object which is used for initialization. And here we use box. If you have a circle derived from rectangle, would be not a good idea. A square maybe derived from rectangle, then we can get a square object sign with new and try to compute total area or whatever we want. So, from this point of view, the code in Java is a little bit simpler than in C++. A little bit, not much. But as you can see here, when we use system out print line box with this, our object B at this moment is a box of reference, and it invokes to string data and to string method of the box type. So at that moment, what we are doing, we are invoking this function. Right? I put there box just to make sure that, okay, we know where we are. Rectangle, the same. This is the equivalent of invoking the output operator, like cout object A. This is the equivalent. System out print line object A. This, I put it just for clarification where we are. So what you will have to do for your assignment, you will have to write everything inside a single file. You have to call your file main.java, main.java, and this class should have to be called main. And for this class, you will have public class main, and you will have this function where you put the code equivalent to C++ code in your main function from A to part 1. And after that, you will have class, not public, class employee, for example. Not public. And you write all your code for class employee. And then you have class salary employee extends employee. And you put everything there. And you will see when you run the code, all classes will be constructed, and you have for each class a new class file in the same folder as main. Okay, so now how do you run a program like this? Because I have everything here, we have to compile first. Okay, so we compile. And when you will compile your file, you will get the same setting kind of. For each Java class, no matter that it's public or not, you will get a class file like I've got here, and box. Okay. So when you get to that point, it means that you don't have syntax errors. But first you have to compile, and after that, you have to run. And you get output for rectangle. This is what I put there, and object A, as I said, comes from to string here, which says length, whatever value I put, 20, width, 26, and area, blah, blah, blah. So this is what we get from here, right? And then for the box, it's of course you can declare here a new object and initialize with box. You can have box my b equals new box, and then work with my b instead of this. But this example is constructed like this to show you the polymorphism Java way. Okay? Objects of the base type initialized from derived type objects. And at that moment, because they will be the same type, base type, you can construct arrays of those objects, initialize, go through the array, and compute the pay, total pay, and display them with system out, print line, employees index. If you have overloaded toString for M4. So it's not a difficult assignment, but I think that it will help you to think a little. Any questions? You can construct more objects, construct an array of rectangles and initialize them with, sometimes with rectangle objects, sometimes with box objects, construct a for loop to compute the total area, just to get you into details. And then you can move to your assignment. Right, so with this, you have everything what you need in order to run, to solve your assignment. Okay, let's go. We have started talking about inheritance. We looked at interfaces, polymorphism, probably for your assignment, you will have employee as an abstract class and salary employee abstract classes. You don't need interfaces. Okay? Whenever you have some implementation, remember, you have to use abstract classes. When you have a type with no method implementations, you have interfaces. And we talked about polymorphism. What are we covering now is casting and instance of. So, casting, it's a big issue. And in particular, when inheritance is involved, because you can convert from derived type to the base class type. This is called slicing. This is normal. You have derived class with lot of data. Part of this data is coming from the base class. Therefore, when you convert your derived type object to the base class object, you have enough information to fill the information for the base class, what data are needed. The other type of conversion for the base class to the derived class is a dangerous thing. Normally you don't do it, but C++ allows it. And sometimes even in Java you can do some kind of such conversion. But for our point of view, we avoid converting from the base class to derived class because the derived class will have missing parts. Remember, the box comes with the data height. If I convert a box to a rectangle, okay, I know who the width and the length are. But if I convert a rectangle to a box, the height is not defined. So this normally shouldn't happen. Very rare exception, but it's above our learning for the moment. This is allowed. Anyway, what happens? A similar situation with what we have seen. This is a base class, and circle is derived from the shape type. It's a derived. So normally, we should be able to assign a circle to a shape. A circle to a shape. So create interface reference. We have D and set base class reference to derived class object. And this is fine. The base gets the base part from the circle, fine. The interface reference gets the interface part from the circle. The circle, remember, was derived from shape and implements drawable. So this is working fine. Typecasting, converting. We have the similar setting. S is a shape, circle is C is a new circle, and with this assignment we are chopping the circle to casting to a shape. With a simple change, we are a little bit in unknown territory. Notice that we have S constructed from a circle, and then we construct another circle which hopefully was initialized somewhere with a new circle. From our point of view, we should be allowed to assign C the value S, because both are circles, correct? This is circle, this is circle. But the compiler says no. From my perspective, this is a shape. And this is something more. So be aware, as I said, this is a circle. It has height, width, and length. And this is a shape. It has width and length. And if you ignore this part, you say, assign to C the value S. So I know how to set up W and L, but who is this? Okay. In general, this is the problem I mentioned before. With this setting, because we are dealing with two circles, normally our shape should come with that extra H. It has width, length, and H. But the system looks just as the type and does not allow. So you get an error. The way to fix the problem is just put, like in C++ casting, circle in front of S. As a compiler, look, you should be able to convert S to circle because this is how it was defined. So you help the compiler recheck the type of S. So be aware of this situation. Explicit casting is required. This assumes that the programmer knows what it's doing, but there are cases in which you have a lot of types derived from one type, and we might have this situation. The base class is shape, from which we derive circle and rectangle, but they are on different branch, right? And we create the base from a circle, a rectangle from a rectangle. And we forgot that S was initialized with a circle. And we say, okay, R should be the rectangle part of S. But this is a big mistake of the programmer. S is not coming from a rectangle, is coming from a circle. In large code data, these mistakes can occur easily. So this type of exception, class exception is triggered. And it's normal because this is a shape, and here we have circle, and here we have rectangles. They are both shape, but they have different data members and characteristics. One possibility to avoid mistakes is every time when you want to do assignment between objects of specific types, you use an operator which tells you what is the type of the object. But every time the code can become quite long and tedious to understand. So there is this instance of which returns true if this is indeed a circle. And normally the code appears like that. After you declare the object S of shape type initialized from a circle, if S is instance of circle, do conversion. Else, if S is instance of rectangle, in other words, S comes from a rectangle, then do conversion. This is one solution, but is considered not the best, and it's a sign that the design of the solution was not the best. Maybe you should think again about your classes. So, the use of this operator is to be avoided if possible, because there are some elegant solutions and they are implemented with patterns. We will see. Design patterns try to solve some complex problem to avoid instance of. So, we talked about the object class, which is the parent of everything. Once again, object is a concrete class. You can declare objects with default constructor and then convert the object to your rectangle class. Very easily. What we have touched on was some of the method in the object type, which is to strings equals and clone. We have talked about abstract classes, interfaces, and this will finish the discussion about inheritance. One lecture for a topic which is quite extensive. It has many bits and pieces. Maybe for proper use of derived classes. What you have seen is enough for small examples and for your assignment. But in real life, you might need to think more about C. If you implement more interfaces, do you have to provide behavior for each method provided in the interface? Yes, you have. Can an interface list more than one method? In general, yes, it can. So there are things which we haven't covered, but it's a beginning. Java generic programming, parallel template programming in C++. It was introduced in Java 5 quite late, and the first attempt was not very successful, but they have to prove it. And lately they change it, they come with better approaches. For consistency reasons, they now have a lot of ways to deal with generics. You will see when we talk about. So here you have good websites. Java has what is called the collection package, where we have the equivalent of containers in C++. Collection deal with groups of data of the same type. And those collections come in different form, you will see in a second when we look at some scheme of classes available. And then, if you add S, collections, we are talking about algorithm. Functions you can use. The syntax for these generics types is much simpler. But one issue which is not as simple in C++ is Java does not allow operator overloading. So comparing two elements, one A is less than B, you need comparison for sorting. You can't go without it. In order to provide comparison between elements, you have to implement a method which is called comparable. So we don't have operator overloading, but a method overriding. The collections are part of this package, utilities, and it has a lot of classes, data structures, as we will see, lists and sets and vector, event models we don't touch. What happens when mouse, when you enter a window, this is an event. Date and time, how to deal with different time zone, how to deal with different languages, and so on and so forth. But the most used part is the collection package from Java utility, because it deals with common data structure. As I said, similar to containers. And then we have these data types provided via three type of construction. Interfaces, so these have no implementation, but they have in place some method. The base of everything is interface collection. From there we have queue, list, and set. They are derived from this. They are also interfaces. No. So you can't construct objects of this stack. Then we have abstract classes. Abstract queue, abstract list, abstract set. So the behavior is given by interfaces, sorted set, navigable set you can move through. And then the concrete classes, the one you might want to use and you normally use. And from this group, we will look in some details to the array list vector. Other than that, you might have heard, and the list, might have heard of other courses, the hash set, which is a clever way to construct data so you find elements very easy. The stack, we have mentioned it. Priority queue elements are stored in terms of how high their priority is. So there are some numbers to give their priority. So this is interesting, and if you look at the way this is organized, you see that each class, concrete class, has only one parent. But a class can implement more than two interfaces. If we go here, because this implements list, in a sense, linked lists implements list as well. On the other hand, it implements double-ended queue. So very few, if you try to find what concrete classes implement more than one interface, you have to try quite hard. There are not too many. But it's interesting to notice these three types. So remember, interfaces put in place behavior. These put in place types of objects, organization, and then they together get instantiated in the concrete classes. So here we have the list of what is provided in a collection. Why we need collection to be interfaced. What is common to all groups of data. Add an element. This is proper Java, this is UML, simplified UML. So in all collection you can add a single element, you can add another collection, you can clear the collection, you can check for emptiness, you can use an iterator, so Java uses iterators as in C++. You can remove an object, no matter that is a list, is a set. Removing an element is common to all collection, so it's a prototype which is part of an interface. Being an interface, there is no implementation. What is interesting, because everything derives from object, remove, I don't know what, integers or student type or element type, doesn't matter. Object type will be used for all derived type. It's good. And this was why it worked. Right. So the most used one is list, which defines a collection of elements arranged in sequential order. So the list interface is, as you can see, dictating how vector, array list, and linked list will behave. The difference between vector and array list is very little. They have a lot in common. The difference appears in concurrent programming. So from our point of view, it doesn't make much difference. But when you deal with synchronization and concurrent access in the internet, working on the same databases, then these are important issues. And the vector was introduced with the first generic approach, which was discovered not to be very good. And they tried to fix it with array list. Therefore, array list is considered a little bit better. So, how to use a vector? All containers work with reference types. You can't have simple int or float. Around these types, there are classes introduced by Java, and you can assume those classes come equipped with what you know for your integers. So, all start with capital letters and have full words. And then you declare your vector object with, you will see the constructors come in a lot of flavor, but what I use here, a constructor with 2 arguments, which sets the capacity tree, and every time when the vector has to increase its capacity, it adds 6 new cells. In C++, the approach was every time when the vector wanted to increase its capacity, it was doubling the capacity. Here they said, okay, memory might be deficient, and we increase with a given number if necessary. So, by default, initial size is 0 if we don't specify, and you can get it with the size method, and capacity gives you what is the allocated memory. We add 2 more, 3, 4, and then because we have exhausted the limit for capacity, notice it jumped to 3 plus 6, 9. When we have these 4 elements, the size is 4, but capacity not. Current size, capacity. What is strange is that you can, because of the vector was designed a little bit shaky, you could have added objects of different type. This is a vector, we will see. The type was not specified, it was just vector v equal new vector 36, and then you could have added integers double float. This was the previous approach, and it was a mess. But as soon as you put the type, the compiler will check. Now, this is the problem. Initially, to find an element, you have to use contains and use new integer. So you have to say, convert 2 to this reference type, because otherwise it's not possible. To display the element, you were required to use enumeration. This method was quite verbose, as you see the enumeration, and initialize it, and then while you have element in the vector, print next element. It was very cluttered. But now the list is the array list is much simpler to use. Sets have a little bit more information. They use binary tree, and for hash set, they use hash tables. So either binary trees or hash tables can be used to organize data. and they have a different performance in terms of searching. Searching with, depend on how large the hash tables are. We will stop here, I think we are, yeah. And we will look at these things to give you an idea of what are the differences between providing generic behavior. It's very different compared to C++ templates, this approach, because of safety reason in principle. But we will stop here. You won't work with generics, but for the tutorial, I think you have something with lists. So whenever you need to answer questions for the tutorial, I would recommend you to try to do a little bit of investigation in Oracle documentation just to make sure that you think. Thank you very much. So see you next week on Monday for finishing this, and we're talking about design patterns. There are simple questions about generics and about